So good to see all of you. I am so delighted to be here. I cannot tell you how much I wish I was there with you all in person. Unfortunately, that was not possible quite yet, although I was just telling some of our colleagues there that I am going to KubeCon in a couple of weeks in person. So I am it's a few weeks later than you all have had a chance to do, but I'm looking forward to having that in-person experience as well. So I am going to go ahead and share my screen and we'll get started. Let me make sure I choose the right monitor. And I will start with the presentation. So those of you who know me know that I'm notorious, come on, there we go, for consuming all of the time that I have. I will try to keep it a little bit shorter than the 45 minutes. But since it's the last session of the day, maybe I'll be able to take some questions going over as well. So as you just heard in the intro, thank you very much for the intro. I have been doing cloud and cloud native for a while, since longer than we've even been talking about using the term cloud native. My background is that I've been a developer my whole career, went to university for computer science, spent my early years writing software, and was very fortunate to get into web architectures, which kind of led me over into eventually the cloud. And as you heard, I spent a lot of time with Cloud Foundry. I also have spent the last 5 or 6 years in the Kubernetes space. And what you see up on the screen is that I'm the author of a book called Cloud Native Patterns. And the reason that I bring that up is, well, obviously, here we are at Cloud Native Day in Switzerland. So Cloud Native Patterns, of course, has a little bit of it has quite a bit of relevance there. Now, this book in particular was focused on architectural patterns for the software. And I'll say a little bit more about that in a moment. But I wanted to start with this intro before I even get to the title slide, which is what I want to talk about here today is what I call cloud native patterns for ops. So the book that I was just showing you is more for the dev and the architecture of your software. But it turns out that there's cloud native patterns that are required on the operational side as well. And that's what I'm going to talk about today. So again, let's back up a little bit and talk about cloud native. Well, cloud native, another word that was very closely associated with cloud native was microservices. Now, I'm not going to go over all of the details here. We've had lots and lots of talks over the years around why microservices. And of course, there's all sorts of benefits that are not just benefits in terms of resilience and the strength of your code and the way that it's running, but there's also relationships to organizational structures and the way that individual software developers and operations works. And of course, DevOps, as was mentioned in the intro, has been an area that I've focused on. Now, as we started to build out these microservice architectures, we started realizing that as we broke our big monoliths up into these microservices, we took on a burden that we didn't have before. And that burden, of course, were things like, now, how do I deal with networks where there weren't network calls in between? Or how do I deal with this more dynamic environment that comes with cloud native? The fact that my services are going away and coming back, and when they come back, they might be at a different IP address. And so how do I find and do service discovery? And so people started writing about these things. And I don't know about you, but I started attending talks and understanding what some of these elements were and realizing that there were a whole host of patterns that we had yet 10 years ago to define and really kind of codify And that's exactly what my book is about. Is so after many, many years of working with clients and implementing those patterns, I wrote about those things like service discovery and retry patterns and exponential backoffs to your retries and those types of things. Now, this particular article was written in 2014. Also in 2014, we had people like Martin Fowler starting to write about this. So this was a blog post that he wrote in 2014. And I bring this out because I think it's very interesting when you look at the main themes that he had in this blog post. First of all, he's pointing out here that the moniker on the left is you must be this tall to use microservices. What he's talking about are some of these additional patterns that you need to understand to be able to play in the microservices world. We can't just break our monoliths up, deploy them, and expect them to work well unless we understand some of these other patterns. But look at the patterns he's talking about. He's talking about provisioning. He's not talking about the architecture of the software. He's talking about something that is arguably a little bit more operational, or monitoring. That's certainly operational as well. And then frequent deployments, rapid deployment. So these are starting to hint at, as Martin Fowler often does, as he's looking ahead of the game, he's starting to talk about operational practices. Now, I bring up one of my favorite slides. So this is a slide, a screenshot that I took from a DevOps Enterprise conference. So DevOps Enterprise Summit is the conference that Gene Kim puts on twice a year, once in North America, once in Europe. Of course, they've been virtual like every other conference for the last year and a half. But this is a presentation that was given by Jonathan Smart. At the time, he was at Barclays Bank. In the meantime, he's acts as a consultant now. But what's great about this slide, and he has a very clever way of presenting it, is you'll notice, I'll draw your attention to the spot where it says dev and it's circled. And what he talks about is we have a lot of these practices that we've understood, even practices in terms of development, the fact that we do Kanban or we do frequent releases, constant releases. And he points out that even though we're really, really good at that software cycle, the development cycle, if you look more broadly across the entire landscape, there's so much of the software, the holistic software development process, that is not yet quite so agile. On the left-hand side, we have a whole bunch of planning things. And then on the right-hand side is arguably where operations comes in. So on the right-hand side, while we've gotten good at development, we've gotten better at the software architectures of our software, we haven't evolved as much on the operational side. So that's why I'm going to talk today about the cloud-native patterns for operations. Now, I'm going to start out with what is GitOps. And I promise you that I'm not just going to start defining GitOps and talking about GitOps in the abstract. I promise you I'm going to make this very concrete. But I want to get a grounding first. I want to do the definition, and then I'll back up and show you how some of these patterns that we put under this GitOps umbrella support this cloud-native operational patterns. And the whole point here is that GitOps is a pattern that is an operational pattern that takes this concept of cloud native from software architectures and starts to apply cloud native patterns to operations. So, quick definition of what GitOps looks like. So we have some runtime environment, and that runtime environment is where we're going to host our software. Now here I'm showing it as a Kubernetes logo because so much of the software that we're building these days runs in Kubernetes, but that's just one example. There's no reason why we can't apply these patterns, these operational and these resilient patterns in runtime environments might be virtualized machines. So virtual machines, more IaaS. It also doesn't mean we can't apply these patterns to, let's say, serverless, something like AWS Lambda or some of the equivalents. But I'm going to talk about it from the Kubernetes space because I think that's the space that many of us are spending a lot of time with. Now, when it comes to operations, we have a bunch of humans that are needing to take care of things over in this runtime environment. Now, obviously, there's a whole bunch of screen real estate between the humans on the far left and the runtime environment. And that's what I want to fill in now, is incrementally how we bring that in. Now, the first thing that I want to point out is that the notion of GitOps introduced this interesting idea that Git is a central part of the operational practices. Now, many of you might be thinking, well, I've been storing things in Git for a long time, not just my source code, but I've been storing my configuration in Git. So am I doing GitOps? Maybe, but maybe not. There's an important annotation on this slide so far where it says, it points out that we've got Git as a store, but it also points out the interfaces to Git, the Git hub or the Git lab or whatever your user interface is into Git. And it has an annotation there that says that is the interface to operations. It's not that I'm storing my configurations in Git and then I'm going over to some other console and I am invoking some script. I'm checking out a script from Git and I'm invoking that script or something along those lines. It's that my operational interface is Git. And that's it. I'm not doing, and you'll see as we go through the operational patterns why that's important. Because if we start to use other operational interfaces, we can introduce some challenges into this cloud native operational pattern. And I'll say more about that in just a moment. So we're using that as the interface for operations. That's the only place that I'm doing ops. Now, obviously, that means that I need to introduce some type of automation so that when I am using Git as my operational interface and I do a commit in Git, something needs to happen. If I'm not going to go run that script, something's got to run that script, and that's the automation. So there's some automation there. Now, again, you might be thinking, well, I've already wired that up. I have automation so that when I do a Git commit, I have something that automatically runs that script. But again, there's an annotation that I'm going to apply to this slide to say that there's something very special about the way that we do this in a cloud native setting. And that is that the automation that's happening here is convergent. That is, it's constantly checking and seeing whether there's any corrective action that needs to happen. I, as a human, don't need to go and do something manually. I've got a convergent system. Now you can see why it was a little bit of a cheat on my part to say I'm going to start with Kubernetes, because Kubernetes is inherently a convergent system. And then there is finally this notion of a closed loop system, which says, well, sometimes I'm going to have some type of a robot that is going to make a decision on something that's going to happen. It's not that the human is the only one that's making operational changes. We can have automation like auto scaling that can make modifications to the runtime environment. The important thing is that we want to close that loop so that what we have in the Git system, in the Git store, is consistent with what we are running in the runtime environment. So another comment about this convergent, I really want to bring home this point about a convergent system, is again, it's all about these constantly converging loops. And we're familiar with this now, quite familiar with the notion of actual state of the runtime system and the desired state, which in this world of cloud native operations, we're storing in a store like Git, and we're constantly converging. Now, I call out this slide to point out that there isn't one big convergent loop. We've found value in breaking up that convergent system into convergence around delivery and convergence around operations. And when we link those two things together, that's really what we put under the GitOps umbrella. And so I'll come back to that punchline at the end of the talk as well. Okay, so that's pretty darn abstract. So I'm talking about GitOps in this very, very kind of theoretical and academic thing. But I want to bring us back to, well, what are our aims? What are our goals? What are we trying to do in the first place? And really what we're trying to do as a whole in the industry is we're trying to get better at doing software. We just want to get better at delivering value to our customers through our digital offerings. That's the end goal, is to serve customers better. And so we have to ask ourselves the question of this academic thing that I just talked about, this abstract notion of GitOps, how does those cloud native operational patterns serve this goal, which is to serve our customers value much better? And here I'm going to bring up something that perhaps many of you are familiar with, and maybe some of you aren't, but some of you may recognize this as a infographic, a graphic that I didn't build myself. It comes from the State of the DevOps report, which is something that's published by the DevOps Research Assessment Organization, which was an organization that was founded by some of the names that we all know in the DevOps community. Nicole Forsgren, Jez Humble, yes, that Jez Humble of continuous delivery fame, and Gene Kim, who was the co-author of the Phoenix Project and the author of the Unicorn Project. If you haven't read those, you really need to read them. They're really fantastic. And what they have done in their work, and this is detailed in more detail in the book Accelerate, is they have found that there are certain IT practices, and you'll see how many of those IT practices are tied to the operational practices in particular, that are correlated to high, medium, and low performing organizations. Now, you might say, what defines a high, medium, and low performing organization? Well, the highest performing organizations are the ones that have the highest customer positive sentiment. So net promoter scores, customer net promoter scores are the highest. They're the most profitable companies. They are the ones that are gaining market share, gaining customer base, those types of things. And the lowest ones are the ones with the most dissatisfied customers, the ones that are losing market share, the ones that are losing money, those types of things. And they, in fact, took some data and they did machine learning. They didn't prefetch the answer that we were going to have 3 buckets or 4 buckets. They took this data, they did some machine learning, and they found some clusters. And they found those clusters based along the lines that we see on the left-hand side. And so they found this correlation. And when they first did the work years earlier, they found 3 clusters. And then a year or 2 later, when they did the work again, they found that a 4th cluster had emerged. And that's what you see in the gold column, the one that's labeled elite. So we started to see the really high performers even dialing things up a little bit more. Now, they didn't prefetch these 4 attributes that you see on the left-hand side. They studied quite a number of other attributes, and they found that these were the 4 attributes that emerged as the strongest correlation between these very successful companies or less successful companies and their IT practices, and very much DevOps practices, dev and operational practices. Now, what we'll see here, I'll just briefly cover them here, which is that those practices that correlate well are things like deployment frequency. So the more frequent a company deploys software, the more likely they are to fall in the high performer or the elite performer bucket. The shorter the time between code complete and realizing that value, making it available to customers, the shorter that time, the shorter the lead time, again, the more they correlated with a higher organization. So those are two attributes. And then there's what I would argue more around the kind of resilience of your operational practices. So the very bottom one, change failure rate. How often did one of those deployments cause a problem? Well, we want to limit that. We want the change failure rate to be less. And the change failure rate being less, again, correlated with high performing organizations. Now, in the event that there is some type of a problem, either due to a change or some other kind of some failure, how long does it take for you to restore the service back into a functioning state? That is also an important attribute. Now, the coloring wasn't mine either. So the coloring is the green and the blue. And I like to correlate those colorings to personas. So there's the developers, the development part of the phase. And in fact, they're not just the developers, but they're increasingly the ones who are responsible for operating their applications. Now, they're not necessarily responsible for operating the entire stack. And that's where platforms like Cloud Foundry come in or Kubernetes come in, because we also have a platform team that are responsible for the platform that the DevOps teams are running and operating their software on. So the developer and the DevOps individual is responsible for kind of that rapid cycle in delivering value to the end customer, while the platform team is responsible for resilience, security, compliance. And we're going to talk about some of these elements as we go along. So with that, I want to go back to, and I want to study how these operational patterns that we sometimes put under this GitOps umbrella support these types of IT practices. So starting with the ones that fall under this category that are more along the development and the DevOps engineer, let's study deployment frequency and lead time for changes. So going back to that DevOps persona, the first thing that I want to call out is that one of the things that we found valuable in the GitOps approach is that, again, developers are responsible now for operating their software. Well, developers have a familiar set of tools. And it turns out that one of those tools, which is Git, and all of the practices that they've built up around Git, is something that we found very valuable if they can transfer that skill set over into the operational patterns that they're doing. And it's not the old days of source code control. It is a very rich, automation-driven and automation-supported experience around this. So it's not only that we're storing the code in some shared repository, it's that we have collaborative patterns that we've been able to apply to that. We have, if you take a look at there on the right-hand side and you look at the commit history, there's things that bots are doing on our behalf. You see in kind of the center slightly to the left, you see a whole labeling structure. Then we've also introduced certain patterns, behavioral patterns, where we can put in things like looks good to me, and that looks good to me tag that we put in kicks off some of that automation. And so applying those patterns not only to software development, but to the operational. So we're storing configuration now, and we're driving some of this automation against the configuration while we're collaboratively looking at all this stuff. That is something that we found to be very valuable. So that is certainly one of the patterns, one of the operational patterns is to take what has worked well in the earlier parts of the software development lifecycle. Remember the screenshot with us, Jonathan Smart, that I showed you? Yay, we're really good at the dev side. We're extending those patterns into the operational side, to the right-hand side. So that's one thing, is the familiar tooling. Now, another thing that is very, very important, a very important pattern for this cloud-native operations is self-service. We need to move away from ticket-based systems. We need to move away from this pattern of, well, the developer wants to do something, but now they depend on somebody else to fulfill some of the things that they need to do to push their code out into production, to get it into the hands of the consumers. And so self-service is a very, very important concept. Now, I want to take a moment to emphasize that it's not the self-service that we might all be familiar with. We are all familiar, of course, by now with AWS or GCP or Azure, where we have the self-service ability to get kind of infrastructure things. What we need is not just self-service capacity, but what we need is self-service operations. What that does is it takes the self-service nature of infrastructure and it adds to it. It really causes us to look at it from a different lens. It says, not only do I need that infrastructure, but I need a set of things on top of that infrastructure that are going to allow me to do things like have observability, and then the ability to affect what's going on in that infrastructure, but do so in a very safe manner. What that's hinting at is that you'll see in a moment that I'm going to bring back that platform persona. So it's not self-service infrastructure, it's self-service operations. Now, as I said things like observability, and I said things like being able to affect things in that infrastructure, I immediately started thinking about the Cloud Native Computing Foundation, the CNCF. As some of you may know, I'm on the technical oversight committee for the CNCF. And in fact, I'm preparing for a keynote that we're doing at KubeCon in a few weeks. And to give you a little bit of a hint, we're going to talk a little bit about the tags, or what we used to call the special interest groups that are under the CNCF umbrella. Well, there is a tag for observability. There is a tag for runtime. There is a tag for application delivery. So many of the concepts that we're talking about here map directly into the agenda of the Cloud Native Computing Foundation, which is to make cloud native ubiquitous, not just cloud native software architectural patterns, but operations as well. So this is very synergistic with the theme of today's conference, which is cloud native, of course. So again, the concept here is self-service. And as I promised, in order to do self-service, but to do it in a safe way, we need to bring in this team that is providing a platform that allows the developers not to become experts at IAM policies and some of those underlying infrastructure elements. It provides them a safe environment where they can still do self-service and they can do self-service operations against that. So I'm going to call out a couple of things that are in that. I'm going to call out security and compliance as well as resilience. And let's take a look at the patterns, the operational patterns that we are codifying into concepts like GitOps that support this agenda. So first of all, let's drill into security and compliance. Now, if you remember, we talked about GitOps in the abstract at the beginning. Now let's pull this a little bit more concretely here. A lot of the continuous delivery practices, the way that they work, is depicted in this slide. We have the software development, the earlier stages of the software development lifecycle, the code changes, the unit testing, the checking into a repository, the changes of configuration. We're doing that, again, we're doing that in Git. That's our interface to operations. And the traditional continuous delivery approaches say, all right, I'll apply some automation against that repository, and I'll push those changes out into the various runtime environments. Now you can see that I'm not super excited about this. And I'm like, there are some challenges with this approach. And those challenges include things like, now you have an attack surface for hackers. And we saw this with the breaches earlier this year, where it wasn't that a runtime environment was compromised. It was that the software supply chain was compromised. And this type of continuous delivery approach creates an attack surface that doesn't just compromise your development stage or your production stage. I have credentials for dev, staging, and prod that are all in this continuous delivery system because it needs those credentials to push out into these runtime environments. So that's a security challenge. If instead, and now remember, the reason I can do this is because we have focused our operational patterns on a convergent system. What I want to do is I want to turn those arrows around, and I want to say that each of these environments, the development environment, staging, and production, they're all responsible for only themselves, and they're responsible for converging to the system that's on the left-hand side. So now each one of those is individually responsible. Now, that doesn't mean that your staging environment or your production environment can never be compromised, but the compromising of the dev environment doesn't inherently compromise the production environment. So what we're talking about here is we're talking about pulling into my environment. I'm the environment, and I'm responsible for my destiny. I'm responsible for pulling my configuration in. And that in and of itself is an operational pattern that is part of the DevOps approach that inherently provides more security than some of the, I would suggest, non-cloud native operational patterns. So that's one thing. So now that isn't the entire security position, security for cloud native and cloud native operations, but it's one example that I wanted to share with you. Now, you might remember that it was security and compliance. So the next element that I'm going to bring out is, let me talk a little bit more about that compliance. One of the things that we do with compliance is there's really kind of two patterns. One, which is kind of a pessimistic compliance posture, which says, before I can allow anything into my runtime environment, I'm going to have a ticket-based system that is going to stop the train, and I'm going to wait for somebody to go in and do a check that we're meeting all the compliance requirements. And there is an element there where you have to bake some of those checks, and as many as possible, and hopefully you can get to close to 90% of those compliance checks so you can shorten that manual compliance check that needs to happen. But the more you can do that automation, once you satisfy your compliance folks in the organization, then there's a second element that's really important to compliance, and that is that an organization needs to be able to prove its compliance. And that proving of compliance has to do with auditing. Because this is the interface for operations, because Git is the interface for operations. And remember, we even have the closed loop. So if there's some automation that is changing the runtime environment, we're making sure that we're recording that back into the Git system, well, Git naturally has an audit history. So that is something that we can take advantage of from the perspective of using that Git environment. So this built-in versioned audit history is another operational pattern that lends itself to these cloud-native systems. So those are two very strong things that correspond to that part of the picture. So that's security and compliance. Now, what we've been talking about here so far is to enable those development practices of deployment frequency and lead time for change. So security and compliance, even though it's provided by the platform team, is really supporting these shortened development cycles, development and DevOps cycles. Now, there's a number of others here at the bottom of the screen, which I'm going to uncover step by step. And that is, let's take them one by one. Time to restore service. So if something does go wrong in my deployment environment, it could be because of a change that I've just applied to the system, or it could be some type of a failure. How quickly can I recover back to my runtime state? And that's where I want to come back to, what does Git offer us there? Well, the interesting thing here is that Git is a source code control system that stores an entire representation of the current state, the entire representation of some entity that Git is storing. Every single node in the graph has the entire state of the system. It's not that they're storing deltas. Way back when, we thought we were being efficient by storing deltas in our source code control system. But the downside of storing deltas is that each one of the nodes doesn't store the complete representation of the system. I have to go back and perhaps replay all of the steps to get a representation of the current state of the system. So that was something that worked really well, because you'll see in just a moment that the current state of the system, and that's been a constant theme, what we want running in the actual state is exactly what we want stored in our source code control system, in our Git system. So having the entire representation is advantage number one that lends itself to this cloud native operational setting. Now, this has a dependency though. I've got a complete representation in Git, has a dependency, and that dependency is that I need my runtime system to be immutable. Or if somebody applies a mutation to that runtime system, I can't just allow it to go unnoticed. And what I'm talking about here is, let's go back to my runtime system. I've got my runtime system and it's working great. Somebody comes along and they do the modern day equivalent of SSHing into a box. And what we do there is we introduce drift. So in the days where we had virtual machines, an operational person could go in and SSH and make some configuration change somewhere in that virtual machine. These days, where we run in a Kubernetes-driven containerized environment, we think that it's immutable, but in fact, it's not, because somebody can kubectl apply, which is the equivalent of SSHing into not just a box now, but an entire environment, and making a configuration change. And now that configuration change differs from what is in my Git system. Well, remember, I talked, first of all, about pull. We talked about the runtime environment being responsible for itself, and we talked about the security benefits of that. Well, there's another benefit here, which is, remember, it's a convergent system. So that convergent system is detecting the fact There's now a difference between the runtime environment, the actual state, and the desired state. And what you can codify into your GitOps practices now is you can codify compensating behaviors. One way you can do it is you can say, well, you know what? When somebody makes a change, does a kubectl apply? They've made a change to the runtime configuration. I'm just going to revert it back. Now, you probably aren't going to want to just revert it back and confuse somebody who said, well, wait a minute, didn't I just apply a change? You probably want to send a notification as well. Or in some environments, you might want to have a switch where you say, you know what, I'm going to stop the automatic reconciliation, or I'm going to change the reconciliation to only do notifications so that I can come in and then maybe turn on the automatic reconciliation again. So these are some of the patterns that you need to be working with. But remember that what we were talking about here was the time to restore a service is very much enabled by the fact that, well, if I've got a complete representation of what I want my environment to look like, when something does go wrong, I can just simply say, hey, convergent automation, go back to exactly what you saw in Git, exactly what's stored in Git. Well, that only works if you're always starting from the same state, the same blank state. So it's immutability. We have not introduced any drift. Okay, so we're coming to the end here, and I want to talk about this last thing, which is, what about change failure? I'm not sure of the exact statistic anymore, but I believe it's well over 50% of the outages that happen in your runtime system come as a result of not some region failure or some piece of hardware going offline. More than 50% of the downtime that we have, the challenges that we have, are because we introduced a change into the runtime environment. Now, obviously, over the years, what we've tried to do is we've tried to have exact replicas of production, and we've tried to do a whole long testing cycle before we can allow things to go. That's why we have change control bodies that don't allow things to go out into the production environment until they've done a whole bunch of checks. But all of those things present barriers to the things that are in green up here on the screen. They provide barriers to frequent deployments and shortening of lead time. So in order to eliminate some of those challenges, we need to have different patterns that we're putting in place to minimize the change failure rate. We need to get rid of those long, laborious, ticket-based change control practices. So there's two that I want to talk about here. The first is, again, I want to go back to this notion of Git offers us a highly collaborative environment. So here we can have many, many different eyeballs that are all looking at this proposed change. So while I, as one of the operational people responsible for operations, one of the operators, might think that this change is okay, I'm going to ask one of my other colleagues, and they're going to get a notification right away. Hey, this checked in. They might get a Slack notification that said, hey, Cornelia just checked something in, and we need somebody to take a look to make sure this is okay. So we apply this notion of code review to application configuration review, get a second set of eyeballs, get that approval. So that's something that can reduce the change failure rate. But then there's also another important thing, which is when I apply this out into the runtime environment, rather than deluding myself into thinking that I've fully tested this in my exact replica of production, and there is no such thing, we all know, as an exact replica of production, is we know we finally admitted to ourselves that there's some level of experimentation that's happening in production. There always was. But now we're actually acknowledging that we're experimenting in production. So what do? We say, let's put some safety nets in place to allow me to experiment in production, but do so safely. And that's where we introduce things like progressive delivery. We're going to incrementally go from version 1 to version 2 of my software. And by the way, we can do that increasingly because of the software architectural patterns around microservices. So that's where we're allowed to do things like use a technology, an open source CNCF technology that was founded by Weaveworks called Flagger, which allows us to do this kind of incremental rollout. And then you can use things like a service mesh, like App Mesh or Istio, to do traffic switching from one to the other. And that's something that we can introduce as a safety net in the runtime environment. So in summary, I just want to go back to this slide, and I'll just build it out very quickly to give you an idea of the final, all of the different patterns that we applied. I think there's 2 more. So these are the cloud native operational patterns that I was talking about. Using familiar tools, using something like Git, which has these patterns around collaboration and automation. Being able to use a pull model to make environments responsible for themselves rather than having systems pushing out to them. And then some of these other things like having a complete representation, ensuring that you don't have any drift introduced into your runtime environment. Those are all the operational patterns that can be applied to make your cloud native system not only be a great software architecture, but have a great set of operational patterns. And finally, the last thing that I want to say is remind you that when we talk about these convergent systems, convergence is incredibly important, but we're applying that convergence both in terms of delivery, that's where I was talking about the pull model, as well as operations. And that's where the progressive delivery was a perfect example. So progressive delivery is more on the continuous operations side. The pull is much more, and that's where the open source project Flux, which is also a CNCF project, putting together something like Flux in the continuous delivery space with Flagger in the continuous operations space, putting those 2 things together, and that's the umbrella of GitOps. So with that, I have, as usual, consumed my entire 45 minutes. I'm happy to stick around for a little bit, but I thank you so much for your attention. And if there are any questions, I think my moderator in the room is going to facilitate that. So thanks so much.